Well, good evening. I hope that you can hear us. It's a pleasure for me to moderate this roundtable about now. We are moving to technological centers and companies that collaborated with us during these years, developing solutions or contributing to our projects. One thing, I have to start a time. Let me first introduce the people that are in the table. I will start by Eduardo. Let me check the other. Eduardo, that is from Thales Alenia Space, that is there.
Hi, can you hear me? Hi, everybody. I'm Eduardo Bani. I'm from Thales Alenia Space. I work in Madrid, and I'm here because actually we are building a geostationary QKD satellite in the framework of the CDTI plan de recuperación, transformación y resiliencia. Sorry, I always forgot the name. Anyway, and that's why I'm here. And it's a pleasure to be here. Thank you, Andres. Thank you, Vigo. Thank you, Marcos.
I think that the next one is Gabriel from Gradient.
Okay, so I'm Gabriel Carral from Gradient. We are here we have a poster also to showcase our results in the PCCC in collaboration with Sesga and Ubigo. And I work in Gradient as a senior quantum engineer. And we work in quantum communication, so that's why we are here.
The next one is Diego from Bahia Software.
Hi, good afternoon to everyone.
Push.
Yes. Hi, good afternoon to everyone. I'm Diego Beltran from Bahia Software. As we are currently working in the innovation department in quantum computing, so thank you, Andres, for the invitation for today.
The next one is Alexandre Rodriguez from Mestle Lab.
Hello, I think it's turned off. Oh. Hello, I hope you can hear me. Yeah. So I'm Alexandre Rodriguez, as Andres said. I work as a software developer in Mestre Lab Research. And we're here because our company has made, alongside with Sesga in collaboration, a quantum investigation project on how to simulate NMR spectra using quantum computing technologies. So thank you for your attention.
Finally, but not the least, is Carmen, but in this case, I moved to Spanish because she's not comfortable with English. So, Carmen, por favor, introduce.
Sí. Hola, yo soy Carmen, soy por el Centro Tecnológico de Automoción de Galicia y bueno, estamos aquí gracias a la invitación de Andrés y bueno, no me siento muy cómoda hablando en inglés, con lo cual me voy a explicar en español.
Well, first of all, thank you very much for being here and for accepting our invitation. I know that for some of you it's difficult to be here because it's far from your workplace. But in any case, I will stay with Thales Alenia Space because you have a very nice project that is Garbo. Okay, so in case of your company, how do you see the future of this technology, the QKD technology that you are developing now?
Okay, first of all, it's a very pleasant name, but our client, CDTI, doesn't like it. So we are rebranded as GeoQKD. So, but anyway, actually we build satellite as Thales Alenia Space. And we build all space-related stuff, from satellite to space station to whatever. We don't do rockets yet. We will do in future, maybe. Why we do QKD? That's a very clever question. We don't know. But someone came to us and say, okay, we need a quantum link between two cities. And we ask, in a satellite, right? And they say, yeah, sure, for sure, in a satellite. So we built QKD mainly because we close the gap where the fiber cannot arrive. So fiber has a limitation depending on which technology you implement. But when you move to satellite, you cover large portion of the Earth. If you go geostationary orbit, you cover 1/3 of the Earth. So yes, with 3 satellites is always the theory. With 3 satellites, you can cover the whole Earth, and you can provide services to all the people that wanna pay for your service. Actually, so we build satellite. We built QKD satellite to close the gap. And we actually see a bright future for QKD, especially in Europe. Otherwise, we will not be there. And we implement in Madrid. We are implementing photonic labs, not as big and as wonderful as those here in Vigo, but we are starting. In all the other sites on the company in France and Italy, we do have also deployed and implemented some QKD, and we are doing QKD there. And we are a major player in EuroQCI in Spain with GeoQKD. We are a major player in other European projects. So yes, we saw an opportunity, a business opportunity there, and we enter.
Okay, thank you. Let me move to Gradian, because Gradian is software in the telecommunication sector. So which is your view about the future of the technology, the quantum technologies in this sector?
Okay, so just getting from the telecommunications sector, which is the main area of activity of Gradient. On the side of QKD, we see like two main improvements. First is to make QKD, put it everywhere. So for instance, the case of satellite QKD is quite paradigmatic, because with this new space, like the industry, space is getting like full of private initiative. So to provide a QKD service within a satellite, especially small satellites, needs a lot of improvement of QKD to make it like miniaturized and compact, so cheaper. And I think that's one of the routes that QKD should take or may take, which is making it like less expensive and less and massive, so to speak. And on the other side, there are also, in quantum communications in general, I would say that what is required is this development of enabling technology, like quantum memories or quantum repeaters, that will take a step forward and like devise a full-fledged quantum network, which also involves computing, sensing, and QKD, of course, as a part of it, a security part of it.
Okay, I have a question for both of you, because today we have seen different proposals for solutions. One regarding the use of fibers in order to cross, for example, the Atlantic Sea between Europe and USA. But there are other possibilities that use satellites, geo satellites. That is the project that Thales is developing, or you cited they use the low orbit satellites. My understanding is that these technologies are complementary, but we have seen, for example, in the previous presentation, that the clouds can be a problem for the satellites. So which is the solution that you can see for the future? Satellites, mixing technologies?
Definitely. I mean, as I said, geostationary satellite covers the Earth, but only cover a portion. So, and are very stable, actually. So, when you start to illuminate a portion, you actually point the telescope in the satellite, with, for example, in Madrid or in Vigo, and we hope in clear sky. You point the satellite, and you can maintain the link virtually forever. Obviously, there comes some limitation, like you've got the sun, you've got some intrusion in your satellite that can damage the equipment, and then obviously you can go in a bright, you can go in a daylight bright, and that can be a very dramatic problem, since you got more noise. Depending on the technology that you employ, can be a very limiting factor. So virtually, the geostationary gives you the stability for those area on the Earth where you can have very low clear sky, and you wanna keep all the key material that you may distill in those very few moments on the Earth where you can do it. So this is the main advantage of the geostationary. On contrary, it's costly. I mean, it's very costly, a geostationary launch, not only building the satellite, that maybe the no, it's costly even that. Sorry, it's everything is extremely costly, and going for a LEO solution, it's actually the complementary side, where you can have higher detection rate, since your link budget is better, definitely, but you have got the limitation of the field of view of your satellite. So there are complementary technologies. It really depends on the use cases. We use one or the other. So it's easily one operator, that could be a telecom operator, can be a satellite or not, should implement both technologies to provide a useful service for their clients, obviously. But it really depends on the money that those operator has and what are their users. So it's really depend on the use case, using one technology or the other.
Yes, I just want to add, in the low Earth orbit case, yes, you are limited to the overpass of the satellite on top of your ground station, and if there's pollution, like solar pollution, or the sky is cloudy, will decrease your key, your DCL key. So you have to accumulate key and like predict the demand according to your customers, how it will be. So you always have key to give them and establish the connection. But yes, there's a lot of effort in like trying to put all this technology into a service that some people find useful and pay for it. But yeah, the LEO case, you can, the advantage is that you can put smaller satellites.
Okay. We have to move to the computing part. So I will start with Diego. Diego, your company developed a solution for distributed quantum computing, that is Polypus. But we are curious about why your company has selected this area of quantum computing for the future business. So can you tell me more information about that?
Yes. So thank you, Andres. As at Vaya Software, as we have an innovation department where we specifically work on new state-of-the-art technologies, we have the capacity to experiment with new technologies without any interference with our business products. With that being said, as from almost 2 years ago, we decided that quantum computing is going to be extremely relevant in the near-term future. We strongly believe that it's going to be applied to many different use cases: industrial optimization, advanced simulations, quantum communication, of course, and quantum machine learning. In some of those areas, we strongly believe that some of them are going to be very related with some of our business use cases. And that's why we decided to enter in this early stage, because we believe that as it has a significantly steep learning curve, we strongly believe that being able to start using quantum computing this early, we are going to have a competitive advance regarding other companies when the clients start to demand quantum computing. That's basically our main focus now, to be prepared to when the market, the clients start to start questioning about quantum computing.
Thank you. The time is running very fast, so I have to move to Alexander. You are a consumer of the quantum computer mainly because you are a leading company, you work for a leading company in the sector of analysis or NMR. So why, not why, what do you think about the experience that you had using quantum computing for your area, and which is the prospects for the future in your opinion?
Okay, so I would like to just give a very brief insight on our company. So as you mentioned, with all of the tools that the biotech sector uses to analyze the NMR spectra, which is a physics experiment of spectroscopy. And I think it's because of that, we are always working hand with hand with the necessities of the biotech sector. And for example, our case of use is the simulation of an NMR spectra. And in that scenario, the classical solutions are sometimes a bit limited because sometimes some calculations are too costly and cannot be tackled with classical solutions. So I think quantum computing is interesting because it allows us to surpass that classical limitation. Okay, so that means, for example, a pharmaceutical now can work with bigger and bigger biomolecules they can discover. They are going to have the tools to work with that thanks to quantum computing. I think that maybe the most use of cases right now maybe we do not even know, because I think it's going to open such a new area of possibilities. Okay, and I think that it's very interesting in that context that I do think that classical computation can still be used, but I think there are going to be certain big difficult calculations that quantum computing is going to allow to perform better. I think they can coexist. Okay, but mainly it can, like now we have more tools, we have a bigger space to explore. Okay,
thank you. Carmen. Bueno, Carmen trabaja en el Centro Tecnológico del Automóvil, un sector importante en Galicia y en España en general, y bueno, tenéis mucha influencia en la parte de la electrónica, por ejemplo, para el sector automóvil, entre otras áreas, ¿no? Pero como consumidores de tecnologías cuánticas, que tenemos varias, con computación, comunicaciones, sensórica, ¿cómo veis desde el CETAG estas tecnologías, cómo se pueden incorporar?
Pues, bueno, lo que estamos viendo ahora mismo es que, bueno, nosotros somos consumidores de tecnologías en el amplio espectro de la palabra, ¿no? Yo trabajo sobre todo en lo que es los procesos industriales, en los que, bueno, cada día se tiende más y más a hacerlos pues, automáticos, robóticos. Entonces, todo eso, la manera rápida de poder hacerlo, necesitamos unas comunicaciones muy, muy ágiles. Entonces, una parte importante de la cuántica es la comunicación, la rapidez de las comunicaciones. Por tanto, el poder, por ejemplo, hacer una programación robótica desde cualquier punto del mundo, pues cuanto más rápido lo puedas hacer y sin ningún tipo de interferencia, pues evidentemente va a ser mucho más eficiente. Pues, por ejemplo, la parte de las comunicaciones, la parte de la sensórica es más de lo mismo, ¿no? Ahora mismo necesitamos tener todo sensorizado, necesitamos que todo esté controlado, monitorizado. Por tanto, la sensórica cuántica, muy, muy importante también. Y la parte, bueno, la parte de la seguridad, bueno, la parte que está muy ligada a la comunicación, es muy importante la seguridad que puede aportar ahora mismo la cuántica frente a los métodos tradicionales y clásicos, donde, bueno, aparentemente y se ve que cualquiera puede manejar la información que está ahí. Por tanto, creemos que la tecnología que nos da la cuántica va a ser muy importante en los próximos años en el sector.
Vale, no hay problema. Nosotros colaboramos con vosotros. Nosotros
encantados.
proporcionamos el robot y el sistema de control y vosotros que no tengamos accidentes. Nos quedan solo 2 minutos, entonces una respuesta rápida. Voy a hacer la pregunta en castellano para que la entienda correctamente. ¿Creéis que las tecnologías cuánticas son las tecnologías disruptivas que se han propuesto para el futuro o realmente nos vamos a quedar a la mitad?
Empiezo yo. Vale. ¿Contesto en castellano? No hay problema. Sí, personalmente sí, claramente. Juegan un papel importante. Avances en computación cuántica aquí de los compañeros son fundamentales y necesarios. Y claro, cuando avanza eso hay que proteger las comunicaciones. Y entonces, de alguna forma, entre post-quantum cryptography y QKD, tienes que cubrir esas desventajas que puede cubrir la eventual llegada de un ordenador cuántico y algoritmo Thor, de Shor, bla, 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 bla.
Yo creo que sí, que son...
Que nos queda 1 minuto.
Rápido. Yo creo que sí que van a ser muy rompedoras, tanto computación como comunicaciones, como sensado, que muchas veces se olvida, pero es una tecnología muy madura y creo que, bueno, las 3 van a ser súper importantes en los años que vienen.
Bueno, nosotros, sobre todo donde consideramos la computación cuántica, es como había anunciado también el CESGA en su charla, que es en el entorno integrado en centros de HPC. Si consideras que la computación cuántica es un acelerador, como en su día o a día de hoy son las GPUs, en ese caso sí que creemos que va a ser disruptiva y que va a aplicar a prácticamente todos los sectores.
Sí, yo creo además que... creo además que, por ejemplo, en el ámbito de la química, es la famosa frase de Richard Feynman, ahora es que literalmente tenemos una tecnología que nos va a permitir recrear tal cual lo que estaría experimentando la molécula en un ordenador y podemos avanzar en este proceso del laboratorio in silica. Vale.
Me están llamando la atención.
Vale, yo solo voy a decir que sí, ¿vale? Así que soy súper corto, que sí, evidentemente creo que tenemos que ir por ahí.
Muchas gracias por participar. Ha sido muy corto porque nos han dado solo 20 minutos. Estoy seguro de que podríamos estar aquí 2 horas. Pero bueno, ahora tenéis la oportunidad de discutir. Creo que tenemos un café ahora, ¿no? Entonces, yo creo que tenemos una posibilidad de que podáis preguntarle más cosas directamente. Y bueno, muchas gracias de nuevo por acudir y pues dar respuestas.
Gracias.